Okay, hello, good afternoon, everyone. So hopefully, G, you can hear me. So, di ko alam kung anong problema naman ngayon. Nakakonect yung dalawa kong devices sa internet. Mukha siyang okay. Pero, ayaw pumayag ng UP, LB na mag-share ako from my tablet sa Teams. Pero hindi ko alam kung bakit, pero yun yung ginagawa natin last time. Ano? Pero anyway, so G, can you let us know kung naririnig mo kami? Or ako?
Yes, sir.
All right, thank you. Over the weekend, G shared some nice questions, some nice points, about what we discussed last week. I'll just share the gist of our discussion. Ang una niyang the main question she asked, it was very nice, ay ano yung nagiging epekto ng interpolation when you use them to introduce or to imputate new data into the data set that you gathered. Kasi we mentioned that interpolation is a very nice tool, although it can only be able to, or it can only be used to predict values in the intermediate of the smallest and the largest abscissa in your data set. Ano? Kasi bawal siyang pang-forecast, meaning pwede mo siyang gamitin, yung model na makukuha mo, pwede mo pang-evaluate o pang-estimate dun sa probable function value dun sa loob ng interpolatory interval, which is bounded by the lowest and the largest x value in your data set. So yeah, that's clear. Ang problema lang ay ano yung magiging epekto niya doon sa data set na makukuha. Right? Kasi pag halimbawa meron kang data na say in intervals of 5, pero for whatever reason, your machine learning algorithm can only entertain data set wherein the x's are incremented by 1 unit. So kaya gagawin natin, 0 to 100 yung x's mo, and then meron ka lang ng data ng 0, 5, 10, 15, 20, 25, and so on. But your machine learning algorithm requires values of 0, 1, 2, 3, 4, 5, until 100 to work. Now you can use interpolation, right? So you can fill in the blanks by finding the interpolating polynomial, using the data points with x equals 0, 5, 10, 15, and until 100. It'll get a polynomial. You plug in x's equal to 1, 2, 3, 4, 6, 7, 8, 9, 11, 12, 13, 14, and so on. So in short, you can complete, quote unquote, your data set, right? So and then you can feed that into, say, your forecasting method or your machine learning algorithm that you will be used for forecasting. Now, she mentioned what probably could be a disadvantage or a negative effect of that introduction. Well, for one, you're introducing synthetic data, all right? A data that is created or simulated. So really, you're adding some more uncertainty into the process, right? Because you are trying to predict what will happen using a limited data set, but you added some points in your data set, thus appearing to have a complete data set, but actually those data points that you included are tainted by theoretical error, the one bounded by the formula n+1 derivative of f evaluated at c all over n+1 factorial times that omega function. So really, parang nagdadagdag ka ng data pero hindi siya measured, but synthetic data that is already tainted by some theoretical error, the error that is incurred in interpolation. So in a way, the error from that process will propagate into the forecasting process. So nadadagdagan inherently yung value, but that would be nice to some effect because you can create you can forecast, right? Though pag maraming points na ginamit mo naman, makukuha mo yung behavior ng function, so most likely maganda yung makukuha pa ring effect. So there would be little to no effect if you use interpolation to imputate your data or to sort of fill in the blanks or fill in the missing data. One major concern in that process will be more of causing an overfitting of your data, which is usually the problem in machine learning algorithms. And probably G is very familiar kasi siya yung pinaka practitioner sa ating lahat dito with overfitting. Now, there are two types of possible concerns, major concerns: underfitting your data and overfitting your data. The underfitting can usually is more easily understood, because when you say underfitting, as the word implies, you are not getting the full picture, right? So, for instance, you say have only 10 points. For instance, you have only what 3 points to interpolate, say, sine x from 0 to 2 pi. But we know that that will not be enough, because you will not be able to see the pattern, the behavior from 0 to 2 pi. So nangyayari, kulang yung data mong ginagamit, so you will not be able to model, to get the salient features of the graph. So if you look at a very wavy function, a very oscillating function, so if you only use limited data, you will not be able to capture the oscillatory behavior, lalo na kung patsi-patsi yung data mo makukuha. So that's underfitting. You have less points, or you have insufficient number of data in order to get a general idea of the pattern in your actual data set. Now, the another problem is overfitting, which is sometimes caused by fitting too much or too perfectly in your data set. So you have, say, thousands of points. And then, for instance, one good example is when you interpolate. If you have 1,000 points, then you will get a polynomial of degree at most 999, right? So you are capturing the behavior, but you are assuming a polynomial behavior. So you have sufficient data, pero inassume mo that that data will follow the pattern that you have in mind. Our pattern is a degree 999 polynomial. So we can fit perfectly all those data points into the pattern that we have, but we are assuming that pattern for the data. So what if in between it's not a degree 999 polynomial? So that's why overfitting can be a cause of trying to perfectly mimic the data, and thus assuming a certain pattern that might not be inherent in the actual observable data. So parang inassume mo na, if you're using cubic splines, or in between two consecutive points, you use a quadratic polynomial, a cubic polynomial. So between those data points, you are making the assumption that the pattern behaves cubically, where in fact in nature it could be not, right? So you get perfect fit, but you are imposing into your model another assumption that might not be true. So that's why the perfect balance would be a mix or somewhere in the middle of underfitting and overfitting. There are several measures of overfitting. Maybe we can go through them later, just as we go along. Although mas maganda siyang i-discuss under classification algorithms. So yeah, so we'll go back to that and look at some examples. So going back to G's question, some problem is overfitting. So you have now many data. So after you fill in the missing data through interpolation, you can use that data set now to get a linear model, like what we did last time. We have a linear fit to our data. However, ang problema, inassume natin na may linear behavior na pina-follow yung mga, or hindi pala linear behavior. Inassume natin na merong polynomial behavior yung data na finite in natin. So that might cause overfitting. We're imposing a polynomial behavior to the missing data set, where in fact it could be an arbitrary distribution. In a nice phrase, it is putting a deterministic behavior or a deterministic character to our data set, where in fact it could be stochastic. So that's why a remedy to this is put a more probabilistic method of fitting a curve. Although tayo ay ginagawa kasi natin ay deterministic, fix yung parameters. There could be some Gaussian, you can assume Gaussian noise in the or distribution of the noise. You can also assume there's a Bayesian distribution of the noise or the data set itself. Pero hindi muna natin yung di-discuss yan, kasi kailangan natin ng konting probability theory in order to tackle that, right? But we'll go back to the more deterministic methods. Of course, it has many limitations, but these are the easiest ones. So, unless you find a very ill-behaved data set, then sometimes you don't need to worry about it. And sometimes you can also remedy yung ill-posedness or yung stochasticity of the error, even if we don't know the distribution of the error. Pero sa ano pa yan, next chapter ko pa i-discuss when we talk about numerical linear algebra techniques. There's a process called regularization wherein we try to remedy yung mga ganong imposition of deterministic behavior into a function rather than a more stochastic or probabilistic one. But those are future topics. Let us just go back to what we were doing last time. So we're talking about, hindi makikita ni G, 1,000 notes, and I now remember I still owe you a copy of this. But if you go to my website, andun naman to. Let's see, can we access that here? So if you go to ito yung website ko. You can go to sites.google.com. Send ko na lang sa inyo yung link later. /up.edu.ph/ hindi niyo pala makikita NJAE. So parang ganito yung Google site. So hopefully as we go along, you will be able to create something like this, ano, para rin sa portfolio nyo kasi mga problem sets nyo, you'll use that to make up a website, right? Which reminds me, I'll give you the first problem set today. Hopefully ma-describe ko siya ng maayos. Right, and then you go to teaching. The teaching, all right, may teaching sa taas, and then you can go down and then click this introduction to numerical analysis. Click nyo lang yan, you'll get a copy of the work text that I'm using. So yan yung i-project ko. Ngayon, ito yung ginagamit natin. Ngayon, we're on chapter 2.6 of this work text. Ano? So I think we discussed what happened. So we discussed the limitations of interpolation, right? The Runge phenomenon, plus its sensitivity with respect to noise in the data. Pag nilagyan mo ng say 10 to the -3 error yung data, ang laki ng pagbabago dun sa nakukuhang interpolating polynomial, and we don't want that. We don't want those little errors in the measurement or noise in the data itself to give significant change in our model. And that is inherent in polynomial approximation or in polynomial interpolation. So that's why we look at forecasting methods. And I guess we went here. When we say least squares approximation, where is that? Yeah, when we say least squares data fitting, we have a space of functions. And we want to select from that space one function that is closest to all the data points that we have. And how do you measure closeness? Iba-iba yun. But in this section, we're looking at the least squares fit. So we're looking for a function f hat. F hat yung ginamit natin, such that the expression in equation 19 is minimized. We want to minimize the summation of the error square. Right? Gusto natin square kasi kapag nawala yung square dyan, yung f hat of x sub I minus f of minus y sub I, it could be positive, it could be negative, depending on which is larger, right? And some of them might cancel out. Baka bumaba yung error kasi nagkakataon na nagka-cancel out yung error. That's why you usually use the absolute value of the error and then we square it. That's the least squares approximation. So essentially, what we did last time is to look at the set of all linear functions. We call it P1. And then we select out of the members of P1 the linear function mx plus b that is closest in terms of the least squares error dun sa data set na meron tayo. So it's just looking at, pag nag-drawing ako ng line across my scatter plot of all the data that I have, ano yung may parang pinakamaliit na summation ng mga error square. And simple, hopefully simple sa atin, simple calculus techniques taught us how to find m and b. So we model the error as a function of the unknown parameters m and b, and then we minimize this. And then calculus techniques taught us that you need to find the partials being equal to 0 to get the critical numbers, and they will probably be the best parameters. In our case, na-solve na natin by hand kung ano yung mga yun. Right? And I think, nakita ba natin yung solution dito? I think we found the solution here. So equation 29 gives us the formulas for the parameters. And you see that all of these are dependent on the given data. X sub I, which are your given x points, and y sub I, the given y points. Capital N is just the number of points. So madali siyang i-program. Tama ba? Hopefully, kung matyaga kayong magsulat ng program, puro summation lang yan, makukuha niyo yung M at saka P. Alright? Tapos, ito yung measure of error natin, nasa equation 30. CR, this is the average mean squared errors. So you get the error point by point, f of x sub I. F of x sub I is the function value at our model, the linear model, and then subtract from it y sub I, square mo, kunin mo yung summation, take the average by dividing by capital N, then taking the square root. So essentially, it is a measure of the error for each of the points. Now, question. Kapag polynomial interpolation yung ginamit mo, ano kaya yung value ni R? Diba ito ay sa least squares. Pag halimbawa si F, pinili ko to be the interpolating polynomial. What would be the value of R? Hindi ko pala dala yung pen. Huwag niyo masyadong laliman yung pag-iisip. Ano? So madali lang yung sagot. Ano yung R? Kapag ka-interpolating polynomial si F hat. Zero. Great. Bakit zero?
Kasi yung calculation ko na nag-report na dalaan sa vision of system. Diba, pag-equal sila ng values x na yung and then y sa x.
Right, great. So the value of R, if f hat is the interpolating polynomial, will be zero, right? Because guaranteed sa interpolation, yung f hat of x sub I will be exactly y sub I. Dadaan kasi siya sa lahat ng y sub I. So magzi-zero lang to kung interpolating polynomial yung ginamit nyo. Kaya lang nangyayari nga, in most of the times, pag nag-interpolate kayo, nagkakaroon ka ng isang overfitted model. So kaya ayaw natin ng interpolating polynomial in forecasting, right? So that's why we allow some deviations dun sa forecasted value, I mean predicted value minus the actual value, right? Just to compensate for stability, compensate for not overfitting the data. So kaya medyo nire-relax natin yung condition. Napakalaki kasing assumption yung binibigay natin sa interpolation. We are assuming a polynomial behavior all throughout the data set. Imagine if you have a data like this, which from the looks of it, could be fitted by a straight line, right? Almost seemingly linear yung data. Pero pag nag-interpolation ka dyan, ilang ba data points yung ginamit dyan? 2, 4, 6, 8, 10, 12, 14, 16, 18, 21 data points yung ginamit. Pag nagpa-interpolate ka, degree 20 yung interpolating polynomial, at most degree 20. And it will wiggle up and down. So you're assuming that between 2 points, there's a degree 20 polynomial connecting them. So yun nangyayaring overfitting. All right? So gusto natin siyang i-avoid. So did we write a program for this? Hindi ba?
Question.
Yes.
Yeah, this is where approximately applicable lang po siya sa data set na linear behavior. Kapag mag-develop behavior yung
Yeah. Good question. G, hindi ko alam kung narinig mo yun. Gio is asking, applicable lang ba yung linear fit, yung least squares linear fit, pag yung function ay may linear behavior, seemingly linear behavior? Yes, that's why sabi nga natin sa data science, usually ang pinakamalaking step is understanding your data. That's the important thing. You understand your data. So if you are just a reckless modeler, dahil madali yung linear regression ay yung linear fit, lahat i-feed mo dun sa linear fit algorithm, which will give you answers right away. Pero maganda lang siyang gamitin kapag linear yung data. Okay? So pag meron siyang seemingly linear data. So intuitively, why will you fit a line if parabolic yung itsura ng data? So you don't do that. And you will see that when you measure when you find R, the average mean square error, medyo malaki yun. Hindi pala medyo, lalaki siya. So that's a signal for you na huwag siyang gamitin. Kasi hindi maganda yung linear fit. For instance, you have an example here. Kita niyo mamaya. Ba, ito yung data set. Now, maganda ba na mag-linear fit dyan? Of course, it's always subjective, right? So, posible naman meron. In figure 31, you can draw a straight line. Yun nga lang negative yung slope. So, pag ganun yung line, which could mimic your data, but parang mas okay yung parabolic, right? Because you can see a parabola from here. Pag ganyan, mag-drawing ka dyan. Next time, dalhin ko nga yung pen ko. So, pag ganyan yung pag-drawing, so mukhang mas maganda. So you have to really look at what's the appropriate fit, and we'll do that later. We'll shop around for what's the best fit to our data. All right. Now there are several ways on how you do this. Ano? Of course, dun sa equation 30 natin kanina, given na yung x at saka yung y, ito sa equation 29 pala, given na yung m at saka b, so you can generate your least squares without any fancy method, right? So, pwede nyo siyang gawin. So, here's an example. Hopefully, you can recreate this. So, try to look at it. Then you will see that if I get the least squares fit to this data using a linear function, you'll get this, the one in figure 26. And here, hindi natin in-assume na quadratic yung, hindi natin in-assume na polynomial yung behavior. And it seems that this set of data could nicely be used in forecasting values. Ang kagandahan dito sa least squares fit, ang in-approximate niya yung trend. So pwede kang mag-plug in, you get a linear function. Anong itsura ng linear function? Ito yung linear function natin in equation 31. These are the m is 1.063383 and then b is negative 2.746054. So ito yung least squares linear fit. And then if you want to find the value of x, say when x equals 6, or the value of f hat at x equals 6. So plug in mo lang dito yung x equals 6. So you'll get a forecasted value, even if that x value 6, is outside the interpolatory, is outside the interval determined by the given data set. So this would be a nice forecasting method, especially if there's a linear fit in your data, or your data is seemingly is linear, right? Now, how good is your fit? Well, pwede mo siyang i-measure by looking at the R value na sinabi natin kanina. The R value is 0.171283. So you just make a table, kunin mo yung f of x sub I, plug in the values of x into f, you get your f of x sub i's. That will be your predicted x sub i's. Compare it to the given y sub i's. Subtract them from each other, square the results, take the summation, get the average, divide by capital N. So you will get 0.171283. Since this is the average squares of the error, gusto natin mababa yun. We want R to be as small as possible. However, I have some problems with the value of R because this will give me Ayan, sorry G, na-disconnect kami or ako. So hopefully we're back. Pero mas kukunti yung signal ko ngayon. Yeah. Okay, so yeah, I was saying kanina that I have sort of a with the average square errors or the mean square error as the sole determinant of the accuracy of the method. One reason is how small do I want it to be small? We know that we want R to be as close to zero as possible. But how do I interpret 0.17? Is it good enough? Because this is just the average of the square differences. So if my data ranges from my Y values ranges from -1 to 1, then 0.17 might be a good measure of error. If my Y values are between, say, 0 and 1,000, yung error na 0.17 piece by piece would be a small number. Pero what if my data set consists of Y values starting from 0.02 until 0.04? Ganon kaliit yung mga values nila. So a difference of 0.17 is very large with respect to the Y values that I have. That's why I usually want to look at the relative mean squared error. So I want to divide the R value that I got, which is not to be confused with the person R value. I want it to be divided by the average of the Y. Ayan. Hopefully hindi na ako ma-disconnect. Sorry about that. G, balik tayo. So, all right. So that's why I want to compute the relative error, the RREL, the relative mean squared error, to give us a percentage P, right? So here we have a 12% fit. That might be good, although there's no really a threshold to be followed. Di ko alam, G, kung sa industry, what is your MSC? Ano yung RMSE na industry standards? Meron bang ganun kayong pina-follow?
Not sure lang, sir. Sorry. But
Alright, no
meron.
worries.
I'm not sure
Yeah.
lang po kung
Mhm.
ano yung...
All right, yeah, thank you. So merong industry, but I think that's not too far from 10%. Usually kasi pag sa math kami, G, pagka lumampas ng 1%, malungkot na tayo. So that seems to be not a good fit. Usually in math, we want degree of precision, say, parang 10 to the minus 6 is still big, or 10 to the minus 8 is still big. But in practice, even engineers, they're okay with 5 to 10% in the real world, because mathematicians are too ideal. But in the real world, you don't need that degree of precision. So usually around 10%, 15% RREL, or relative MSC, is already fine, right? Now, a nice point that was brought earlier was, Sir, lagi po ba dapat linear? Well, not always the case, because it doesn't make sense to fit a line to something that doesn't resemble a line. So that's why data visualization is a good first step in order to decide what type of curve to fit to your data set. For instance, or by the way, before I go there, sorry, wala ako sa script. Isang problema nga pala ng polynomial interpolation is the sensitivity to perturbations in the data that you have. Remember, data could come from physical measurements, and no measurement is perfect, so there's always an inherent measurement error. But those little errors can significantly affect the result of interpolation. That's why we say that interpolation is very sensitive to noise, because a small change in the y sub i's can cause a significantly different interpolating polynomial, as we have seen in one of the examples earlier. But in interpolation, we look at this. I did a quick test. So limbawa, I get erroneous data, I get noisy data, instead of the perfect circles, yung mga nasa circles sa screen, which is the same data points that we used kanina, but I perturb them by just a little value, and I get the excess, the orange excess you see on screen, and I find the polynomial, the least squares fit to the orange excess. Gusto kong malapit pa rin yung sagot, all right? Because we don't want to deviate too much from what is in reality, right? So we want to model reality, but we cannot capture reality in terms of measurements. So that's why we want the model from measured data to be as close as possible dun sa model para sa reality. So if I run the entire thing again, use equation 29 to get M and B, but this time use the orange excess, the erroneous data for our data set, we will get this G, this function over here. And then if we look at how good it is, so it is a 11.77% good. 11.77% lang yung relative error if we compare it to the erroneous data. So almost at the same level. The model of the least squares fit to the perfect data, and the model of our least squares fit to the noisy data are comparable to each other. 12% when you use perfect data, 11% when you use erroneous data. But that's not really a fair comparison. What we're interested is to look at the sensitivity. What's the effect of that small perturbations in the perfect data, right? So how close is f hat, the model from the perfect data, from g hat, the data from the model for the noisy data. And what I do is to say plot them together, okay, in one graph, and you look at and you see that they are almost identical to each other. So that means this modeling technique is not sensitive to perturbations in the data. So that means little deviations in the measurements will not cause a significant effect on the model that you'll get, which is not the case for interpolation. So this is another advantage for least squares fit to interpolation or over interpolation. Then if you see, ito yung graph naman nung G hat, which is the model from the noisy data. If I plot it on top of the scatter plot of the regional data points and the noisy data points, you see that really it's a good fit to either of these models. So that suggests it's better if you're expecting noisy data, which is almost always the case. So nasosolve yung isa pang problema ng interpolation. Aside from overfitting, yung sensitivity to noise ay nada-downplay din, right? Of course, there are some measures that I defined here, but that will not be too important for us. Ano? So, okay. Now, good question kanina, paano kapag hindi linear yung behavior ng data? Say we have something that behaves like a parabola. So it's no big deal. So just perform the model, but this time your space of functions will be coming from P2, the set of all of degree 2 polynomials or less. So dun sa space ng mga polynomials of degree 2 or less, dun ako pipili ng curve na magfi-fit dun sa data. How well do we want the fit to be? Well, it should be good with respect to the squares of the error. So same idea. So kung ang mga candidates ko ngayon ay quadratic polynomials, p hat ax squared plus bx plus c, yan yung general quadratic function. I want to fit a parabola into my data set. Well, kunin mo lang uli yung error. But this time the error, the least square, the squares, the sum of the squares error or the squared errors will just be a function of the coefficients a, b, and c. Alam natin, equation 33, yung gusto kong itsura ng model. Ang kulang na lang, ano dapat si A, si B, at saka si C. Pipiliin natin yung A, B, and C so that F hat will be a good fit to the Y sub X. And what is the measure of the goodness of fit? Etong least squares error. Summation ng squared errors. Oops, sorry. Right? So you see here, this is the function value under F hat if I will plug in the X sub I's. Right? I subtract from it the Y sub I's. I square it. And then I take the summation. Ito yung measure natin ng error. And this is something that I want to be as close to zero as possible. So we want to minimize this E, this expression E, the error, which is a function of 3 variables. Ganun pa rin. You take the partial derivatives, equate them all to 0 to give you the critical numbers, right? So equate the partial derivatives to 0, you'll get equation 34, and then you compute those partial derivatives by hand. You're going to get equation 35, system 35. And using equation 35, gusto nating masolve si B, at saka si C. Right? Of course, you can do this by hand. Ito yung makukuha nating system of equations. If you're patient enough, you can do this. And then, kunin mo yung minimizer nito. You're gonna get A, B, and C. Medyo komplikado yung itsura ng minimizer, kaya hindi ko siya ipapakita rito. Pero we'll ask MATLAB to do the job for us. But you can use any computer algebra system in order to solve equation 36, right? For A, B, and C. And then when you get A, B, and C from a device or from a computer, from an app, then you'll get your model, ax squared plus bx plus c. And that will be the best parabolic fit into your data, right? A quick example, yung equation 48. Medyo outdated na yung example. Makita nyo kailan pa nasulat itong vortex na to. Way back 2021 pa. So, kinuha ko yung stock prices ng Jollibee Corporation from July 19 to August 18. Kasi gusto kong kumita, so gusto kong i-forecast magkano yung presyo ni Jollibee sa gantong panahon. Alright? So, but first, I need to know what would be a nice curve to fit into my data set. So I need to understand my data. Now, I plot it, I use a scatter plot, and this is what I get, right? So ito, nasa table 14, yung prices ng Jollibee stock, yung Y sa buy at day X sa buy. So nag-assign lang ako ng random, nag-assign lang ako ng day 1 ay July, first day ng data collection ko, July 19. Tapos sumunod na ay 3 kasi yung July 19 malamang ay, sabal ba yan 19? Yeah, wala akong data, halimbawa ng July 20 and so on, or July 22 and so on. So I get that data, I get a scatter plot, and this suggests to me na baka naman parabolic yung behavior because there seems to be a parabolic behavior over here, right? I have my X sub I, I get my Y sub I plug those values into equation 36, I will get this system equation of equations, a 3x3 system of equations, right? Tapos, so solve ko lang to, A, B, and C using Mathematica or using MATLAB, I will get these values of A, B, and C. Plug that into the model, we'll get F hat. This is my quadratic fit, right? And then to have a visual feel of how good the fit is, i-plot ko lang si f hat sa ibabaw noong scatter plot. And you see that, yeah, more or less, nakaka-capture natin yung behavior ng data, right? If you want a more analytic measure of error here, kunin natin yung RL na lagi yung kino-compute ko. Kasi para magkaroon ako ng idea, kasi baka na numerator, yung MSC, yung mean squared error, halimbawa baka siya ay 10 point something. Kung 10 point something yun, magpapanik ako na 10 point something is large as a mean squared errors. But I might forget kasi na the y sub i's are in the hundreds. Kasi price siya kasi ng stock. So 190, it run from around 183 hanggang 210. So a 10 peso deviation is not too much of an issue. So it is still good. But that's why I usually go to the relative error right away. And what I get is 0.0181. So there's about a 2% misfit, which is kind of good, right? So kasi 98%. All right, so yeah, at least visually we have, and then I have some more examples here, but I want to go with this. What if you want a more complicated model? Hindi siya linear, hindi siya quadratic. What would you do? In theory, you can use any set of functions that you want. You can expand your set. You could include trigonometric functions. You can include exponential functions. You can include any sort of function that you want sa mga candidates. So that's why in general, yung mga math yung training, they'll be happy to see some common symbols here. Si curly S, siya yung space ng mga candidates ko for the fit. Gamit yung phi sub j, which are, this could be basis functions in say from an orthonormal of basis of functions. Tas linear combination lang yung kukunin mo. But the problem remains, what are the coefficients A1, A2, and AN? Yung phi1, phi2 hanggang phi m ng mga functions, sila ay given. You choose what are those coefficient functions. But the process is still the same. You take the partial derivative with respect to all of those unknown coefficients of your model, equate it to 0, solve that linear system. But of course, the larger m is, the harder to solve the system will become, right? Mas marami kang coefficients, mas marami kang unknowns, mas malaking system of equations, mas mahirap siyang isolve. So yun yung mga pros and cons. All right. So common choices are Chebyshev and Legendre polynomials. But for those maths savvy in the group, pwede nyo i-test yan. Pero punta muna tayo sa mas realistic. Hindi man mas realistic. Mas practical na paraan ng paggawa nito. Ano? So I'll show you how the MATLAB curve fitter work, right? Kasi nakita natin mathematically paano siya ginagawa. Pero ayaw naman natin na every now and then, magpa-partial derivative ka, mag-equate ka sa zero. So somebody might have done this in the past already and collected them in a library of functions, right? Now, I don't know if you were able to download the curve fitter app. Meron ba kayong curve fitter app? Na-download yun. Nung una, wala. So, kung wala kayong curve fitter app, kailangan nyo i-download yung package. Nakalimutan ko anong package. Curve fit package ba yung meron? Kailangan. If you type curve fit, yeah, ni curve fit. I forgot the name, pero you can search curve fitter MATLAB kung ano yung package yung kailangan. And we are lucky because yung subscription ng UP has access to all of the packages. So you can download it. Mahal pala to. Hindi lang pala $500 per year. 1,100 yata per year. So, ay, the lifetime na yata yung 1,100. Pero yun ay yung basic. Bawat package, another $1,100. So medyo magasta siya. Kaya gamitin natin habang meron tayong subscription. So curve fitter app. So go to the upper ribbon, click curve fitter. And then, yeah, you need the curve fitting toolbox. Yun yung nakalagay, curve fitting toolbox. So click that, it will open the curve fit window. Ito. So makikita niya. But of course, before we work with this, we need data set. So you need to feed into MATLAB your data set. All right. So halimbawa, may mga data sets si MATLAB for demonstration purposes. For instance, it has the hand data set. So you just type in your code or in the command window, load space HAHN1, and then you hit enter. You'll see in the workspace, meron na na-create na dalawang variables. So itong hand data set, ito yung data set containing the thermal expansion coefficient ng, kalimutan ko kung anong element. I think it's copper. Naka-record ba ako? Yeah, naka-record ako. So dapat baka copper. So, but I think that's it. So you're given a temperature in Kelvin. Tapos, it will give the thermal expansion coefficient of that certain element, right? Which is a dimensionless value. So yung temp, kung makita nyo sa workspace, yung temp, puro temperature values yung laman niya in Kelvin. So if I click temp here in the workspace, I'll get a 236 by 1 matrix or 236 vector. Nagko-contain siya ng mga values. Yan ay mga temperature values in Kelvin. Wala pong kita nyo. Yan. Hindi nyo naman sinabi na blurred pala yung nasa screen ko. Di sana inayos ko kanina. No? So, yeah. So, makuha nyo yung temperature values. And then yung Thermex na variable, ito yung thermal expansion ng certain element na yan. I'm guessing it's copper. So, ayan yung thermal expansion. Right? And then we want to model it. Okay. Now, so pag na-load na yun sa workspace, ibig sabihin meron ng data si MATLAB na pwedeng paglaruan. So you go to the Curve Fitter app, balik kayo dun sa Curve Fitter app, then click Select Data in the upper ribbon. Okay. And then that will load in the data that you want. You can put the fit name. Halimbawa, ito ay yung thermal expansion. Halimbawa, ito yung expansion. Yan yung gusto kong pangalan ng fit o ng model na gagawin ko. And then X data, meron diyang drop-down menu, sino yung X values na i-feed natin dun sa curve fit. So you can say temp. Kasi yung thermal expansion is the reaction of that element to the temperature. So temperature is the independent variable, that's the cause. So siya yung gawin nating X. And then you see that as you enter data, nag-ano na siya, nag-create na siya ng scatter plot for us, which otherwise kailangan niyo pang i-code na scatter of data X, data Y, right? And then for Y data, select term X. And then, there we go. Medyo pala decision siya, gumawa na siya kagad ng linear fit. Ano? Linear M yung gagawin ko. But anyway, the black dots are your data points. And then obviously, if you're a reckless user, you'll just use a linear fit, right? At ayan yung linear fit na ibibigay. And you see, I get a linear fit without doing anything. Ibibigay niya yung sa akin. So, hindi ka kumbinsido. Another good thing about MATLAB is it already computes. So let me just close this. It already computes the value. Right? So halimbawa, makita nyo dito sa lower makita nyo yung ilang information. So it will give you information about the model that you got. You'll see here, hindi ko alam kung kita nyo pa, pero na-run nyo ba yung code? Yeah. I think G can easily see this. Pwede siya mag-pinch dun sa Teams. Ano? Pero for those joining us live, hopefully nagawa niyo siya. Dito sa lower right, nakikita niyo yung pangalan. Linear model, poly1 yung tawag niya. Ang itsura ng function ng model ay f of x equals p1 times x plus p2. Tapos pinakita niya ano yung p1 at p2 na na-compute niya. So you can really recreate that the model here, the blue line that you see on the screen is 0.02x plus 7.449. Okay. And then you see how good is the fit. Yung sum ng squared errors, which is SSE, that's 2428. And then yung R I think the person R square ay 0.68. And then the RMSE, ito yung mean squared error, siya ay 3.221. And that is quite big. Kasi 3.221, ano ba yung range ng data values natin? From 0 to 20. So pagpalagay natin roughly order 10 yung ating mga y sabay. So essentially that's 3.2 divided by 10. So it's about what? It's about 30%. So it's not a good fit. And then you shop. So if we don't have any curve fitting software here, pupunta ka na naman on paper, baka parabolic. So you do ax squared plus c, you get the partial with respect to a, b, c, equate them to 0, you solve the system, you'll get your model. Pero here, just use the drop-down button in the fit options on the top. Pwedeng degree 2. Kung degree 2, ito yung parabolic model. And the RMSE here is about 2.02, right? Which is better than what we got earlier, right? What if 3? What if 4? And so on. And with just clicks of button, parang na-disconnect yata ako. G, are you still there? Hopefully I'm still here. Yeah,
Yes,
mukhang di naman ako naputol. Yeah, thank you. So you see how the evolution of the fit. Well, of course, you can take a look at the lower right portion. Nakita nyo dyan yung RMSE. Bumaba na siya. 0.47 na lang siya kanina. Nasa 3.21 yan, right? We want the RMSE to be as close to 0 as possible. So you could do 5. However, ayan, maganda na tong 5. 0.28 na lang yung RMMSE. But you get a more complicated model. Look at here. Ang model natin ay poly 5. So it's a polynomial of degree 5. It's P1 x to the 5th plus P2 x to the 4th and so on until P to the 6th. Yung mga P values with 95% confidence bounds ay andito sa baba. So you can generate that model. And not just that, hindi lang polynomial, yung kaya ng curve fit. Look at the upper ribbon, dito, may drop down pa dyan. Pwede kayong pumili, baka naman pala siya exponential. So you click exponential, it will try an exponential fit, which is not good. It's an exponential function. You look at the top, at the bottom corner. Ang model lang pala pag exponential ay a times e to the bx. All right, so that's simple. And then you get your a and b there. RMSE is 3.73, not good. Pero tingnan mo, baka pwede ko pang paglaruan yung exponential. Baka pwedeng 2 terms. So pag 2 terms na siya, meron akong a e to the bx plus c e to the dx. I have 4 unknowns now. And you see, ang ganda nung pagkaka-fit, right? And only 4 parameters. So the RMSE here is 0.3476, which is close to 0. And then again, we said that the y values are of order 10, so 0.34 divided by 10, so around 3%. Good enough, right? But again, there's a question, overfitted ba yung data? So that's another thing, another good thing to look at, right? Siguro mamaya pahapyawan natin. And of course, you can play. There are some other things here. You could look at the Fourier or the Fourier fits. So ito ay sum ng sine at cosine, the usual Fourier expansion. So one term in the Fourier pala yung base sa kanya. Fourier expansion. Kung 2 terms in the Fourier example, you'll get this. And then 3, you get 3 terms, and then you get 4 terms, and so on. So you can decide for yourself what's the best fit, because you have a library of different functions to choose from. You even have a Gaussian fit, which is a Gaussian distribution. You can select how many terms you want in the Gaussian distribution. And of course, as we expected, the more parameters you choose, the better fitting the model would be. Kasi yun yung pros and cons. Pag gusto mong konti lang yung computation, you choose a small number of parameters. Pero if you want to improve it, there's no free lunch. You have to do some more work. You have to make more computations. Tingnan yung ginawang computation ni MATLAB. Ang daming parameters niya kinonsider. Yan lahat kinompute niya. Luckily sa atin, isang ano lang siya, hindi nga tayo nag-type eh. Pili-pili lang tayo sa drop-down menu kung ano yung paggagamit natin ng fit. But you see, meron pa rin siyang implications. The more terms you consider, the more, pwede ko nga palang i-drag to, the more oscillation sort of that happens at the tail end. So be wary about those things. This could be a sign that the model that we have is probably overfitted. So just some visual indications that occur. Now let me go back. So you can play power, rational, sum of signs in the Weibull distribution. There's also splines, interpolation. Although interpolation will not work kasi may error siya dito sa baba. Dapat yung data ay unique yung X values. Remember sabi natin sa interpolation, dapat yung mga abscissas ay hindi na uulit. I think in my data set, some of the X's, actually may isang X na naulit, magreklamo na si MATLAB. It won't work na. So kaya hindi kagana yan. But otherwise, pwede ka sana makakuha ng interpolating polynomial. Now, let me just go back to my favorite fit here, exponential na dalawa yung terms. All right. Another way to gauge the error, aside from a visual inspection, is to look at the residual plot. At wala nang coding na gagawin, click nyo lang yung residual plot. Okay, it will give you this plot, which will give you a plot or a stem plot ng relative errors, point by point. So that means here, at the first X value, the error is about 2.4, halimbawa. So makita nyo yung deviations na yan. Okay? Nandito pala sa baba, ang dami nyo pa rin makukuha ang information. Ayun din pala yung information dito. So R square, SSE, DFE, adjusted R square, and so on. All right? Okay. Now, another thing na pwede nating paglaruan dito is, say, ano pa nga ba pwede nating gawin dito? Kalimutan ko yung gusto mo. About validation. All right? Kasi one way to look at how well your data learned or your model learned. Kasi it's an example of, say, a machine learning algorithm wherein your input, we taught the machine the pattern. So we fed into it the X's and the Y's, the corresponding Y's. So it did learn, and it discerned that, say, the pattern is A e to the bx plus C e to the dx. And then if we give it an X value, not in our data set, it can compute what is the probable Y value based on the pattern it had learned with the data and the model, the template that we provided it, right? So one good gauge of how well the forecasting is done is to set aside part of your data and call it the training set. And that's the only thing that we will feed into the algorithm. And then we'll reserve a certain portion of our data set to serve as the validation set. Kasi kailangan natin ng sort of may answer key. Sa totoong buhay, wala tayong answer key, right? Hindi natin alam yung mangyayari. So nag-collect ka ng data, you partition it into two sets, a training set and a validation set. So yung training set, yung validation set, there's some, I read somewhere na wag nyo siyang taasan ng 20% ng data. Pero ang ginagamit namin dati ay 30%. But ideally, the training set would be larger than the validation set. If you know G, the standard, you can let us know. Kasi theoretical lagi kami. Pero yung nabasa ko, wag daw sanang lalampas ng 20-25% yung validation set of your data set. So because that's the only way we can validate our model. Or if you have a data set, you feed the entire thing into your machine learning algorithm, and then you gather data again to check, to validate your model. So that could also be the case. Pero pwedeng isang bulto mo na gawin yung data collection, and then you just randomly select what would be my training and my data set. Right? So we can do that here. Let me just end this session and create a new one without saving what I have. So I'll temporarily exit that PerfFitter app. I'll go back to the MATLAB usual. So ngayon, ang gagawin ko ay kukuha ko ng data X. So this will be the part of my X values that I will use for the training. Here, we have 236 X values, right? So I'll just get the first 189 of them to serve as the training X's. So ito yung syntax. Sorry. I'm assigning to the variable data X yung laman ni temp from 1 to 189. Right? So yun yung matitira kay data X. So click that. Nakalimutan ko yung semicolon, so i-display niya yung 189 temp values. And then I'll create another variable. I'll call it data Y. Para siya naman yung training Y values. So kinuha ko yung first 189 kay temp. So kunin ko yung first 189 din kay termex para sila pa rin yung magka-partner. So i-reserve ko yan to be my data set. My training set. And then for the validation, kukunin ko yung X value simula kay 190 o yung pang 190 hanggang dun sa pang 236 na X value. I will store it in the variable val X. Tapos, yeah. Tapos yung val Y, na-type ko na kasi siya nung isang araw, siya naman yung value ng Y, yung pang 190 hanggang pang 236 na Y value. So you write the vector name, parentheses, starting component, ending component. So this would be the 190th entry until the 236th entry of the vector terms. Hit enter. Di na nagpakita ngayon yung mahabang values kasi naglagay ako ng semicolon. Right? So sinopress niya yung information. So meron na akong, makikita nyo sa workspace, meron akong data Y. Bakit wala yung data X? Hindi ko pala na-run yung data X. Meron akong val X. Pero bakit wala rin yung data, yung val X? Hindi ko siya na-press. So ang data X ay ito. Yeah. Bakit? Ayun pa, mabasa yung data X. Tapos val, ano yung wala ko? Val Y. Val X din yung wala. Okay. So yeah, there we go. I have all of them in the workspace now. Tapos, i-feed ko na yan dun sa curve fitter. Balik ko sa curve fitter. Okay. And then I'll select data again. Okay. I'll select data. And now I will feed the training data. Right? So tawagin ko siya, okay, pwede tawagin natin siyang F na lang para maiksi yung pangalan. And then I'll load as X value yung data X, the training X values. Y yung training Y values, mas kakaunti ito dun sa training set natin kanina. I'll press close. And then I'll use exponential curve. Tapos 2 terms halimbawa. Okay. Now the RMSC, the mean